Good. Should be live. Cool. Looks like there's a couple folks on here already with thumbs up. But just for a reference set, it is Tuesday, October 11th, 2022, here with Mike Horton from GEODnet. Mike, thanks for coming on.
Thanks, Nick, for having me.
Super psyched to have you on here. We had done a Gristle Crew talk a while ago where you talked to the crew about what GeoDnet was. And then I realized I don't think we've ever done a YouTube live that was open to the public. So excited that we get to do it together.
Yeah, thanks for getting.
Yeah. Let's start with, for folks who don't know what GeoDnet is, what is it? What does the thing do?
Well, so GeoDnet, we're deploying using token incentivized protocol to infrastructure protocol to incentivize people to put up what we call space weather stations. And a space weather station is really simply a GNSS or GPS receiver that's being used passively to monitor the GPS signals. And from that, because you're putting it up at a fixed location with good clear sky view, you're getting real-time data not about the location, but actually about the distortion to the location, which is caused by space weather. And those space weather effects that are caused by the sun and its magnetic solar wind that distorts the ionosphere then affects all GPS receivers. So by having this network of stationary receivers called a terrestrial network all over the globe, we're able to use that for two primary purposes. The first and most important is to provide a correction stream to other GPS receivers, such as your mobile phone or your car, or if you're a surveyor, your surveying stick, that then allows that mobile GPS receiver to achieve very high accuracy, much higher accuracy than it could receive if it didn't have space weather corrections. So that's the first principle. And the second principle we're working on for the network is to use this network of terrestrial receivers that have a crypto services to authenticate locations that are presented through mobile phones or through cars as being valid and proven locations, immune to spoofing and RF attacks that are not common today, but are increasingly common. There are YouTube videos up that will show you how to spoof your phone's location using a simple RF gadget and some software that you can freely download.
Okay, and that kind of spoofing thing has been one of the problems that the Helium network has faced is the location spoofing. But what I'm hearing you say is that basically this is a solve or a solution for
Yeah,
GPS spoofing.
can solve it both at the minor level. We have very strong guarantees. It would take really a state level actor to try to corrupt a location. It's very, very, very robust proof of location at the minor level, but we can extend that proof of location to devices that use the network and bring that benefit of proven location to actual things that connect into the GeoNet network.
It's pretty rad. I guess most of us take. You've talked about this idea of deep tech. Is that most of us take GPS for granted? Like it's just some thing zinging about the sky, and we look at our phone and it tells us where it is. But there's a fair amount of technology that goes into that. And I think we've all had the experience of walking down the street and the dot on your phone is on the other side of the street. You know, it's not where you are. So this helps fix that.
Yeah, it does. I mean, that your dot is on the other side of the street, quite possibly because of space weather errors in that region, orbit and clock errors as well. So all these techniques for precise location were developed a while ago, but they were just super expensive. So they were developed primarily for the surveying industry, and then they started to be widely adopted in farming and in construction, and machine control. But now people are seeing, look, the hardware cost has plummeted for this high accuracy receiver hardware.
Right.
And you can start to think about using these services in mobile applications and autonomous driving, drones, augmented reality, all types of things that could benefit from having more precise registration of position. And so to do that, you need the low cost receiver hardware that's happening. But at the same time, you need a dense correction network to take advantage of that hardware to deliver the accuracy. The hardware by itself won't deliver it. You need both the network and the hardware working in combination to unlock that high level of accuracy.
Got it. And that's down. I think I'm going to say this guy's name wrong. My Sybil is asking what level of accuracy. I think you said it's centimeter. Is it sub centimeter, or
Centimeter.
those are two different things?
Well, you can get to sub-centimeter over a longer period of time, and this is what people actually, one of the applications of the GeoDnet network itself as a terrestrial network is to be a set of position sensors that, when looked at over weeks and months, provide millimeter level accuracy. And what that's used for is by geodesists and by people in seismology and in earth science to actually physically see the plates of the earth moving around. So there's a whole science community that uses GNSS networks for research on plate motion, understanding tsunamis and volcanic activity, all kinds of things you can do with the data from a scientific and geohazard type of stuff. But normally that takes a while to get to millimeter accuracy. But for a rover, like a mobile GPS receiver, you can get to centimeter accuracy in a matter of seconds if you have a good augmentation network. So 1 or 2 second convergence, you can get to 1 centimeter accuracy if you're near the base station. There's an old formula that's very accurate and used as a rule of thumb, really, that says the accuracy at the mobile GPS in clear sky conditions is 1 centimeter plus 1 centimeter for every 10 kilometers you're away from the nearby base station. So, for
Okay.
example, if you're 10 kilometers away from a base station, you can get about 2 centimeters on the ground accuracy, which is really the requirement that most of the guys in surveying and construction have for, marking a coordinate, marking a land boundary, these types of things. The people that do the drone scanning, which is now super popular to fly drones and scan stuff, they will look for processing that data with RTK corrections or PPK corrections to get to 1 to 2 centimeters of accuracy. So that's what you can get real time. But if you average data from these stations for a long enough period of time, you can get to millimeter accuracy, which is what what the science community likes to do.
Right. They get excited about that. Okay. So let's see. There's a bunch of new terminology in here for a lot of folks. One of the things I heard was there's base station and reference station. Are those two different things?
No, we're using the term interchangeably.
Okay.
Some people call them reference stations. There's a term for these stations also called course stations, which is a continuously operated reference station. And the
That's right.
continuously operated part is important because the space weather data changes all the time. The sun is a fire, so it's like actively changing the ionosphere second to second. So if you don't operate them continuously, they're not so useful. So they call them continuously operated reference stations, but you can also call them base stations for short. And I know some people who have grown up in the helium community and things like to call them hotspots. They're not really a hotspot because they're not, directly providing. Well, they're providing a service through the network. So I guess you could call them a hotspot, a high accuracy location hotspot, but it's just not a term that people in the GNSS industry use much or the GPS industry use
Right.
much. But you could,
Right.
in fact, call them a high accuracy location hotspot if you wanted.
Dig it. So I like the general idea, and we'll get to the use case. We got a couple folks on chat who are psyched on here, including Soren in Romania. And if I remember right, that's around where you have is that where you have the densest
Yeah. So
deployments?
we were really super lucky to meet some Romanian helium miners who really helped us think through what we were doing in the early days
Yep.
after we first kind of launched the white paper.
Yep.
And as a result, we got a really good network. I believe we have the densest geodetic reference network ever created in Romania today, and we're just at the beginning phases of starting to actually utilize that for real applications on the ground in Romania. So yes, we have a really great, evenly dispersed, covering really the whole country very well in Romania with about 230, 240 stations there.
Got it. Okay, and that's probably a decent time to step into the market kind of size and what's out there. Because one of the first questions I get whenever I tell anyone about GeoDnet is like, who's going to use this thing? Is it just going to be a couple farmers on tractors? Like, who are the customers who are going to pay money for this service? So kind of walk me through what does it look like.
Yeah, so the GNSS and GPS industry is a big industry. It's not one you think about every day. It's one you take for granted. But even your phone is using augmentation services. Otherwise, I don't know if people remember back when you would get a standalone Trimble Nuvi for doing driving directions, and you had to wait for like 5 minutes for the thing to converge to a position.
Yep.
That's because it didn't have connectivity to a network. It didn't have an augmentation service. So there's a simple augmentation service that's being used for your phone today, and that's powered by a geodetic network. So there's a geodetic network that's collecting all the ephemeris data and using that to seed the solution in your phone. And that's paving the way for people to think about higher precision services on the phone as well. To give some perspective on the existing market for these high-end services, when you talk about 1 centimeter, that is the high-end GPS market today. That is not a small market in and of itself. There are 2 million. We can pull up some of the market data from the that's been out there. There's publicly available, downloadable market reports on the GPS that are actually quite detailed and quite extensive. But there are 2 million high-end receivers shipped a year, and those receivers are all connecting into some kind of geodetic reference network for augmentation services. And then I think there's a very strong case for these networks now being deployed in what are called mass market applications, including consumer and automotive applications to enhance the integrity and accuracy of GPS services. So yeah, so Nick, I think you pulled up the
Yeah.
market report there, and it shows, a breakdown of the different types of services that are added on top of GNSS. And one of those categories, the gray bar, is the augmentation services. So these are things for improving the integrity and accuracy of the GPS by itself. And that is a big category today. It's a $20 billion category, and it's growing very steadily as these services transition from things that are primarily used in the higher end of the marketplace to the mass market. They're projecting growth of that from 20 billion to 50 billion by 2031. And that's the marketplace that I think GeoDnet is uniquely positioned to disrupt by providing a open service. So some of these services for augmentation are actually quite proprietary. By providing an open service to all the different applications from science users to all the way to a consumer with a mobile phone. It's the same basic principle. You collect the data from geographically dispersed locations using a reference grade receiver, and then you can process that data and create a variety of data products for correction, augmentation, and enhanced integrity.
So I mean, one of the questions then is, are we looking at someone like Apple saying, "Hey, we're going to buy centimeter level accuracy for all our phones," and the consumer never really sees that deal, or is it more like, I mean, the other obvious one is Tesla buying it for their cars, or are these customers kind of other customers?
Yeah, I think you're going to see definitely the mobile phone carriers and ecosystem adopt high accuracy positioning. Google has been at the forefront of pushing it. They've opened up raw data on the Android platform. It's part of the reason that the GeoDnet project's a little bit partial to sort of working on Android first, is there's more open capabilities on Android to take use of this. Google's also been running these smartphone decimeter challenges where they're asking people to figure out what kind of algorithms that can be used to improve the location, and the winners of those contests are all using reference data network, typically public reference data network from, for example, IGS, which is a public reference network, a lot like GeoDnet, but older receivers and not nearly as dense. But it's data that a person who's going to enter into the Google challenge can freely download. So those contest participants are using that. So I think, yeah, it's early days, but I do believe that all mobile phones will eventually use these types of services, and there's activity in the telecom industry to evaluate and to start to use this type of capability for enhanced phone location.
Cool. That's pretty exciting. I mean, if every phone's going to use it, that seems like a big market.
That's a big market. There are a lot of other, new devices too that are going to come on. I mean, robotic lawnmowers. It sounds like a small thing, right? It sounds like, oh, nobody has robot. Actually, robotic lawnmowers are selling like hotcakes, and they all want to consume RTK correction data for auto steering your little lawnmower
Oh,
around
yeah.
your lawn. And it's one, watch the space. We're gonna have some fun stuff and cool applications like that are, kind of pave the way to the robotic future.
Yeah. I mean, that's one of the hard things with these blockchain and meat space project, or the tipping, whatever you want to call it, is that because it's all so new, it's still pretty hard for the average person to kind of figure out beyond the mining side, the getting tokens, like what does this enable that isn't currently enabled? And this idea that you can have these stations all over the world and have this relatively dense network rolled out at a low capital expenditure, capex, is pretty cool. So it's like a nice start.
Yeah, I think that if in that regard, in these tip-in protocols, I think they're all really cool and all have a lot of potential. The one thing I would highlight on GeoDnet that I think is maybe unique to it is that in addition to being able to provide the data at the lowest cost to the industry by leveraging blockchain and by leveraging mining, we can scale the network in a way that would cost traditional Web 2 companies or governments, whoever wants to deploy them, way more, because they wouldn't be able to, take advantage of a person's physical property and their internet connection and things like that. That's really the value add to scale that up quickly. So that's one piece, that we can get the lowest operating cost for a large scale network. And then the
Yep.
second piece is, because we're deploying new hardware and the satellite signals, a lot of the signals are new. I mean, they've been deployed they've just been turned on from new satellite launches really in the last couple of years. To the extent that there is terrestrial infrastructure for receiving these signals and doing corrections, a lot of it's out of date. So if we deploy successfully 100,000 nodes well spaced over the Earth, we'll have the best network ever created. And I think that's unique, that this blockchain project can really realistically say we have a chance, working together as a community, to not only have the lowest cost and best operating expense platform, but also the best quality and the best coverage network of any network ever created. That's very unique. And I think if we achieve that, the project will be fantastically successful, and really can take a very strong leadership position in the entire industry.
Dig it. Dig it. Now, it's exciting to see all of these things. All right, let's do a little bit on. I saw something about Ntrip. We can get back to details in a second. I saw a piece in the chat on tokenomics, and that's probably a good time to talk a little bit about kind of where you are right now and where we've been brainstorming about going. So, Kemper Powell got the hard question there. Let's see if it's correct. Are you seeing this in the chat, Mike, or do you want me to read it to you?
Why don't you read it to me? I don't
Sure.
have the chat open. Where do I get
Yeah.
the chat?
It's probably over on YouTube. Don't worry about it. So he says, I find GeoDnet interesting, but I'm hesitant to buy a node given the token emission schedule, which allocates 80% of tokens to the foundation. Are there any plans to modify the tokenomics?
Yes, we're definitely, that's under advisement, and I think we're going to get a new chart up on there soon. We've been talking about it internally as a team, and we recognize that what's listed up there as on the website for the mining community is too low for us to fully meet our goals. So we will be revising that. Um, that's correct.
Cool.
Yeah.
Super cool. And I think this is it's a neat thing because you guys are a pretty small team. It's not like there's 600 people on the team and everybody's cranking. You got, what, 30, maybe 40 people total? Or is it less than that?
Less than that, yeah.
Yeah,
So there are about 15 people total working
15.
on the project. Yeah.
Okay. And it's one of those things where I see this a lot with engineers and folks who are kind of domain experts is they just don't get back to update the website, but things are actually
Yes,
going pretty well. So
that's exactly right.
that's how it
So,
happens. So let's talk and kind of brainstorm a little bit about the tokenomics stuff, because one thing I think is really cool with GeoDnet is we've been talking about various ideas around density of the network and making sure that the density is correct and not overdense in some areas, just the same way that helium kind of has really blazed a path for everyone and said, hey, this is a way to do it, and then in some cases a way not to do it, is looking at how do you incentivize kind of correct deployment of a bunch of nodes when you have to have a global deployment. So that's kind of let's start with
let's
that.
talk about that. Yeah. So I think we've been studying the data that's being generated from the network, and we published some early data at the Institute of Navigation conference, which is a big event for kind of the core satellite systems to go and share technical data, and preparing data for that and starting to study data that's coming off the network and starting to use it. We do see, variability in the stations, and certainly anyone who sets a station up should get token rewards. But we do see some stations outperforming others, and those stations that are really doing a great job, we want to make sure that they do not, suffer losses from overcrowding or things like that. So one idea is to really incentivize really good deployment through an NFT mechanism, that when a station reaches that level of stability and quality, that they get an NFT that will protect them from future overcrowding, and that they will always earn the base reward level if they're running the station at that level. And then the second idea is to think about how do we incentivize station deployment in areas that are more difficult to get to, or maybe the crypto community hasn't developed as much in. So this could be developing world locations, and we're starting this idea a lot around India, but we hope to apply it to other areas where maybe investing in a piece of hardware up front is a more difficult thing. So ideas of increasing rewards in those locations so there's a faster payback. I mean, that's something that I think is a good approach, and we're going to do that because getting coverage in those areas provides disproportionate value to the network. There are less alternatives. These are regions we know we have people who want the data from. We know we can sell the data to, so they can bring revenue into the project faster. So they're really good to get, to amplify the token rewards there. So that's one mechanism. Another mechanism is to look at remote mining. So basically using a location provider on the ground there, but letting people mine that location by buying the miner. They own the hardware, they purchase the hardware, but having somebody else get the thing deployed for them and maintain the station for them. And that's a way also to, push more deployments in more difficult regions quickly.
Yeah, this remote mining concept, when you'd first told me about that, I thought it was pretty cool. And the more I kind of get my head around it, the more innovative it seems. That basically you buy a miner because you've got the ability to buy 20 or 30 miners, but you don't have 20 or 30 locations. And you say, hey, where is GeoDnet identified and figured out a location for me to put this thing? And it goes there. So if it's in India or wherever, that's kind of a cool idea. And it's something that I've seen, I guess like Helium kind of tried, well, they allowed people to figure it out on their own, which hasn't worked super well, or in some cases with Emirates has had some blowback to the company itself. So it's cool to see you guys managing that internally.
Yeah, and we think that in some areas that we did this test deployment with the Starlink, which we talked about a little bit
Yep.
on the last state of the network, and that thing is now up and running really well. We're getting data from it. We're looking at the quality of their data gaps. They're really very minor data gaps in it, and it's been really consistent. So we can think about something like that is eventually. We're not there yet, but eventually, being something where we can bundle it with GeoDnet and get it deployed into really remote areas where that device is providing fantastic data for the community, for the GeoDnet community of users. And particularly in a lot of cases, some of these really remote locations are super interesting to the science community.
Yeah.
And at the same time, providing internet access to a family in a remote location that wouldn't have had any good internet before in that area. So that's something that I'm really excited about. We have someone who's going to be joining the team in December, who's going to help us work with some of NGOs and work with the UN and other places that are actively looking into how to get geodetic networks into regions of the world that simply don't have any infrastructure for this stuff today. And I think that Starlink combined with GeoDnet is really interesting because now you have multiple parties benefiting. You have the user community benefiting. You have the person on the ground and in that community benefiting from internet access, and then the network benefiting from creating a more uniform global network. It's just wins all around.
Yeah. And we've talked a little bit. I've been talking with Max as well, because Max and I are writing this GEEK, the Gristle King Industry Insider newsletter together, talking about the tokenomics and how to drive installs. And I think Max had talked about, remember there's some reason the airlines don't do this, but they used to overbook flights and then they just pay you to get off. And so this idea of like, hey, start cranking up reward multiples until people start deploying. So, and this is not something that you and I've talked about. So this is not like a
Right.
thing out there, but saying like, okay, hey, no one's deploying in Kenya right now, so every res 5 in Kenya, every location in Kenya is going to get not 2x or 4x, but it's going to get 10x until we get to kind of the correct density there. Now the amount of multiple is that's up to like the mathematicians to figure that out with some kind of bounding
Right.
equation. But just that idea that you've got this ability to kind of push levers and dials around and say,
Yeah.
look, it is no longer important to have any more GeoNets in San Diego because we got enough, but we desperately need them in location X, Y, and Z, and able to control that through the token incentives. That's pretty cool.
Yeah, we need to. I mean, we're trying some ideas. We're gonna keep working on it and refining it. It's critical. I think it's really critical to understand that a network, um, one of these physical infrastructure networks is super valuable in general, but it's exponentially more valuable when it's reliable and the coverage is complete. I mean, the cell phone analogy is easier to visualize than with GeoNet, but the same principles applies. But who wants a cell phone network that drops calls, right? Who wants a cell phone network where they're having to run around, trying to find the one spot in the area that they can get a half a bar? It's really frustrating. There's a huge premium on reliability and quality, and we need to work with the right token incentives to get that done because everybody benefits, and that's the thing to keep in mind. It's like when that network achieves that level of true coverage and reliability, the whole community benefits, and not in a linear, but really in a nonlinear way. It's way more valuable when the network is properly densified and properly reliable.
Yeah. Yeah, it goes back to kind of the early days of helium. You start seeing like a 40x, reward on some hex, and it's like I'm flying there. I'm getting on a plane and going
Yeah.
put a GeoNet miner there. So it gets to be a little bit kind of exciting and gamified, and I think we've talked about that a little bit as well. But that's one of the really cool things I've seen about GeoNet is you're a small enough team and the network is still small that you don't have 600,000 miners on there kind of screaming at you every time you make a change. There's what 1,000, a little bit over 1,000 now, and you're going for 10,000 as the next big milestone.
Yeah, I think definitely. Well, 2000 is the very near term milestone we're trying to get to. And then
Yep.
I think what in the GNSS community, when you hit 5,000, you are in the top, few percentile. I mean, there's only a couple of 5,000 plus node networks ever been built. Um, Trimble's built one. I think Hexagon's built one. There's one in China. But that would really put us in the top tier. So that's a huge milestone. Getting to 10,000, we probably have a realistic position to claim the biggest in the world. So those are all milestones. You get to 100,000, you have really a truly perfect solution. So those are all things I think are doable. Again, looking at all the things that helium has done right. People are quick to point out things that recently have been some challenges or whatever,
Sure.
but they've really done a lot of things right, and they've proven that we can get there. And that proof point is one we want to take those lessons on how they did that and apply those, because it's going to be hugely valuable when we get to that 100,000 mark. It's going to be unbelievable.
Yeah, I mean, if you get to 100,000, no one's ever done that before, so that opens up.
No one's come within a factor of 10 of that. So
So,
it's
and that seems reasonable. And the big thing is just making sure they're well deployed. So it's managing or the tokenomics to make sure that those 100,000 are
yeah,
spread.
they're not all in LA, right? I mean,
Yeah, spread evenly throughout the world.
they're spread. They need to be spread evenly, and they need to be deployed right, and that's a huge benefit.
Yeah. Dig it. I'm going to go back to a couple questions. Let's see. When is the release and when are you going to release N trip to the public? That seems like a technical question, but you might have the answer.
Yeah. Well, it's really saying when are we going to allow people to publicly use the network without sort of working on a kind of point to point basis with the GeoNet team. So first of all, we are working with a number of people on a point to point basis in like Hemisphere, it's publicly known as using our data for some of their services. Um, and we have worked with a couple of other people to do trials and to provide services, and we've done that over Intrip. So if you have a use case you want to try out and we can validate it. We can get you an in-trip mount point, and you can go ahead and use GeoDnet today. But we're not doing a public opening of it on in-trip until we've done more work on just the overall infrastructure, and that we're in position to handle that. But I think that when we do that, it'll drive in, additional growth and usage of the network, which will be super exciting. But we're doing that cautiously, so not to overwhelm the team with support efforts,
Sure.
and also make sure that when we do that, we have the quality and everything that we want to make sure that the market receives it very, very well, and not, oh gee, I connected to it and it didn't work quite the way I expected. We don't want that. We want it to be a really strong launch. But if you do have a case and you need to use some data from it, we're happy to do that. We've done, like I said, we've done that now. We have a number of people actively using the network, in both commercial service and also in trials through the
Dig.
Intrip protocol.
Okay. Cool. I saw a question in the chat about number and names of customers. Can you name any of them, or can you give us numbers on customers you have? The last we talked, you had at least one, but which is more than
Yeah, so
one projects.
I think there are two things we publicly talk about is customers. One is Hemisphere. They have a correction network called Atlas. They suck in data from the global base stations, and then they run it through some of their own proprietary processing, and then they uplink that to actually back to satellites to transmit back down through L-band. So it's a really neat satellite augmentation system that's using data from GeoDnet today.
Mm-hmm.
And that network is expanding, and we're growing that. You see us actively promoting for locations. We've got stations now going into Maldives and Greenland and some other locations. Just had one come online in Germany as well. So that's public and paid. Another case that is pretty exciting is a more local case in Romania. We're starting to enable farmers there for auto steering. This is a very popular application for RTK in the farming community. The GeoDnet team will be actually at a farming robotics show next week in Fresno. Central Valley of California is also a big region for
Sure.
for farming, obviously. And this is an established application. Auto steering tractors is a well-established big market for these types of correction services, and it's really exciting for us to be actually doing that live in Romania today, taking advantage of the work and the early things there. And these are the types of things that, as we get more confident and more, through more of this kind of early phase testing for applications like that, we'll open it up much more broadly for that type of usage. But that's real. That's a commercial customer. Those are the ones I can talk about publicly. And there are a couple more that we're working on under kind of NDA basis where I can't talk about them publicly. I did state in the last AMA and reiterate we have a very important trial coming up in Germany that we're very excited about, that has some big implications for us. And got a few other things in our quiver here that we'll talk about as we can.
Cool. Love it. Yeah, it's good to see that there's actual customers out there and the thing is working. One thing I saw also in the chat is someone had asked, like, can they get a bulk order? They wanted to order 100 or 40 or whatever it was. And this is something that I don't think Helium anticipated early on, the effects that allowing people to do bulk orders would have. Because what happened with the same thing happened with Pollen, with XNet, and with a bunch of these, is that folks with money will come in, they'll buy almost all of them that are in stock, and then they'll parcel them out and take a portion of the rewards as part of what they're doing. Now, I think on one hand, that's pretty cool. If you're a WISP owner and you got a bunch of towers, like, why shouldn't you be able to deploy on those towers and contribute to the network? But what I did see was that there's a bunch of folks who bought a bunch and they're just kind of sitting in their garage because they didn't have locations and they didn't want to hand them out. There are exceptions to that. There's a super cool guy in Chicago named Chris who just bought a bunch and sent out. I think this was Pollen, but sent them out. But how are you kind of handling bulk orders?
Yeah. So in general, we're supportive of it now. We weren't in the early days when we were really, ramping up manufacturing. We did not. We wanted to really keep it as even as possible. So we limited it to 2, and I think that worked out well. We didn't have a any sort of huge problems with the initial rollout of the mining hardware. Only we had a little bit of a slowdown when Shanghai shut down due to COVID, which was totally out of our control. But we caught back up after that. We do when people want to order more miners than a couple. We do try to vet that to make sure, hey, it's not a person that's going to go and do something that we think would be detrimental to the community. But if the person clearly has good locations, or is with an organization that has a lot of locations, we're supportive of that. If it's a person that wants to distribute hardware into a community that we're not well served in, or not well represented in, we definitely are open to that as well. So that we do a little bit of diligence to, again, try to make sure that it's going to have a positive effect on the community. And this is, really at HiFix's discretion. I mean, from a GeoDnet perspective, we just want nodes out there well deployed. But from the mining company's perspective, is trying to ensure that it's not going to create some economic incentive to be nefarious or things like that.
Dig it. Yeah, it sounds like the guy in the chat has just a bunch of locations. So I guess reach out with that. You did say, so there's HiFix and there's GeoDnet. Can you talk about kind of who those two things are and how
Yeah,
they connect?
right. Right. So they're as decentralized as they can be, but they're not very decentralized because they both run through me at this point. But we had a company previously called HiFix that's been involved in IoT GNSS, been working with Quectel, for example, on IoT GNSS solutions and enabling things like location and scooters and stuff. And that entity we use to create the miner reference design and build and ship the miner, as an example, kind of a prototypical miner manufacturer. And we are now so that is separate, is a separate entity from GeoDnet. It is supplying the miner hardware, and it's taking responsibility for that. Following the Helium model, we do want to get additional miner manufacturers on board and further decentralize that. We've had some good ongoing discussions to get additional miners out onto the marketplace. Taking a little longer than I had anticipated. I think hardware design and supply chains and things has taken a little longer. I don't think we're going to see anything really ship before the end of the year, but hopefully as soon as possible there'll be some additional people making and selling miners, and we have anyone who's got a entity or who has experience in that's interested should contact me. And I think that will also help drive the ecosystem.
Super, super cool. Let's see. Right now, you guys have enough stock where you're shipping them within 30 days of them being ordered. So you got enough stock on hand with HiFix to handle demand, but as demand ramps up, people see this, you're gonna have more manufacturers.
Yeah, and that could, at any time we could, I mean, the supply chains are still pretty wonky. So, it's good. It would be good to get this further decentralized, and what our lead time is today may not be what it is tomorrow. I mean, we I think have a good, solid manufacturing and hardware team in China that's really, I think, done a good job to get good quality and affordability in the hardware. But gosh, it is still to this day a pretty messy supply chain out there for building hardware.
Yeah.
Unfortunately, I hope it
Yeah.
ends, but I keep thinking it will. But it is still kind of messy.
Yeah. So one of the ways that you guys have managed that is you saw that there was a glut of helium devices on the market. People bought them, 18 months ago, thinking they get delivered on time, and of course they didn't because this supply chain issue. But now they're out there, and folks are saying, "Hey, I've got these things. I don't know what to do with them." And you guys had seen, with the rack V2s, so just with one specific miner, you can send that in, and we'll send you, as long as you got a good location, we'll swap it out for a GeoDnet miner, and that everybody wins because you can then take the rack miner and either redeploy it as a helium miner somewhere else where you've got a great location, or turn it into a PoE enabled GeoDnet
Not PoE
miner.
enabled, but
Sorry,
Ethernet and Ethernet
Ethernet. Sorry.
based. Yeah, yeah. The racks don't support PoE. That's something that we're looking at
Yeah, you
because
got to
we've
have a
had a
little
lot
injector with them.
of
That's right.
a lot of requests for PoE. So that's something we're definitely studying, and it may be that same type of methodology may be a good way to get one in the short term. But yeah, I mean, Rack is great quality hardware. It's based on a really nice, well, I mean, everybody knows the Raspberry Pi, right? I mean, it's the super mature platform, not meant really for outdoor usage. It's really an indoor, it's not something. The Raspberry Pi has its limitations, right? It's not telecom grade hardware, but on the other hand, it's easy. It's easy to use in an indoor environment, and then cable out to an outdoor environment. It's easy to do software upgrades on and things. So from that perspective, because it's a pretty well understood piece of hardware that does that, and it's pretty easy to either deploy as a Helium miner or as a Helium plus GeoDnet miner type of thing. We see real value in that, and we're going to use those in locations where we want to get hardware out to places that Wi-Fi, which is what the HiFix miner uses, is not an appropriate network. Wi-Fi is, great where you have a good Wi-Fi network, but in some places it's just much
It's not
simpler to
there.
turn it on and plug. Yeah, just turn it in and plug in an RJ45. That is a little simpler than configuring SSIDs and passwords and things like that. So that we're going to put that hardware to good use, and and we're looking at can we extend that program further or where we can go with it. And we also want to be clear we're not in any way negative on Helium or Rack. We think they're both. Helium is a great project and Rack is a great company. Just trying to take advantage of supply chains are limited. Building hardware is why rebuild hardware when there's potentially hardware that can be reused.
Yeah, yeah. I mean, it's not like many people are going to throw them away because you can sell a pie, but it avoids e-waste getting created.
Yes.
So it's a pretty cool thing. Let's see. I saw a small question. I think Reuven had answered this, but we'll just double tap it. Are the stations affected by snow and ice? And really, the bigger question is like, are there any kind of temperature or locations where you can't put one of these because it's too hot, too
Yeah.
cold, whatever?
So let's separate the station into the two component pieces. There's the antenna, and then there is the receiver and its power and Wi-Fi connectivity. The receiver should be in a temperature controlled location within reason. We're saying sort of 0 to 50. Maybe you can go to -10 to 60 if you push it a little bit, but please keep that receiver in a decent temperature controlled location. The antenna itself, the white disc that receives the satellite signal, it is intended for outdoor operation. It is fully sealed. It is temperature qualified over a full outdoor temperature range, and you don't need to worry about that other than getting it installed with clear sky and stability. Those things are designed to not have too much snow accumulate on them. We have had our station in Norway. We posted some pictures of this on Telegram. Back in the winter months, got completely packed in with snow, and it still worked pretty well. I think it's the frequency bands of the GPS signals are pretty good at penetrating through snow.
Yep.
So we did not. I asked actually because it came up um, on Telegram. We went and looked at the data. We also asked our customer to look at the data. When we had these pictures, the host had shared his pictures of it with 2 or 3 inches of snow on the top, and everything was good.
Right.
So I think in general, it's not nothing to
Snow's
worry
not a big
about.
deal. Okay.
Yeah, don't worry about too much. I mean, I think at some level, if you had like 3 feet of snow on top, it might start to become a
Knock it
big
off.
deal.
Yeah.
But hopefully, these antennas are installed, at a location above the roof line at a place that's not going to have that much snow accumulation. Maybe there's some snow accumulation, but not the level that would be problematic. And certainly, a couple of inches doesn't seem to be problematic.
Dig it. And then the stations they're getting signals every second. Like it's not like a helium miner where you're getting, you might get a blast or it might ping out every 10 minutes. These things are getting like there's a solid stream of data coming through them.
Yes. So they're tracking. You can look at data on the console, but anywhere a well installed one will be seeing anywhere from sort of 32 to 45 satellites at a time, depending on the geographic location. Certainly, some of the stations, like in the South Pacific area, get the most. I've seen some of those push over 50. So they're getting signals all the time, and they're uploading data every second um, across all the different constellations. So you've got satellites, you got multiple frequency bands on all the different constellations: GPS, GLONASS, Galileo, Beto. Depending on where you are, you may be picking QZSS up or IRNSS. So you are getting a decent amount of data, and we are uploading that data continually. It turns out that that's somewhere in the 50, 60 kilobits per second range. So it does add up to be gigabytes per month.
Yep.
So that makes it impossible to do that kind of data upload over something like Helium, but it also at the same time is not gonna use up your entire broadband plan either. It's still
Right.
a small fraction of what typically people have for a broadband plan.
Take it. Okay. What about one of the things that is that comes up for folks is when they install it, there are really two questions. How do I know I installed it right? And then what is installing it right? What does installing it right look like? Because it's
Yeah.
different than helium. You can't have this thing shaking around in the wind.
Yeah, so um, it's pretty easy to know if you installed it right because your token rewards go down if you didn't. But the key points: clear sky. We call it a 10-degree elevation angle. That means you don't. If you're thinking about this is the antenna here.
Yep.
You don't want trees that are intersecting a 10-degree slope from that. We have some drawings on the in the manual and so forth for that.
Yep. And that's
And you
all the
want
way out to the horizon. That's not just nearby.
horizon, right? That's
Yep.
out to the horizon. If you violate the 10-degree elevation angle a little bit, it's not going to kill you. But what you don't want is something that you don't want to put it on a balcony where, on one side you have no elevation angle. I mean, it's like 90 degrees. You
Yep.
basically can't see any of the sky on one side. That's not good. You want to get it in a location where you get as much of a clear sky as possible without overhanging trees and things like that. And you want it to be stable as possible. You want it to be installed physically, rock solid so it doesn't move around, because those movements, we're using the fact that that antenna is perfectly stationary in order to measure the space weather and able to provide a stable reference for the mobile receiver. So if the antenna is moving around, then the correction data quality will go down, and the rover who's using data and one way or another from that station, its accuracy will go down. So getting really good, stable installation is key. You don't need to put the thing 50 feet up. If you've cleared that elevation angle, there's no premium on getting it higher and higher and higher. And it makes getting it stable more and more difficult. So we recommend, just clear your roof, clear the surrounding obstructions, and get it stable.
Dig it. And I think you told me one time like you should be able to do it should be stable enough you can do a pull up off of the mount.
That's ideal. Yeah, not every installation meets that, but that's you, man. You've got it really installed good when you feel like you can put a lot of force on the installation, and it doesn't move the antenna. That's that. Then it won't blow around in the wind.
Yeah. And you're doing some pretty cool stuff. There's like this progression of how you're issuing out the tokens. So we talked about the placement before, but at first it was just basically if you had the thing plugged in, you got your whatever number it was per
Right.
day. And then the most recent one was making sure that the SNR, the signal to noise ratio,
Right.
is good. And
Yeah,
then what's the next one going to be? Is it strength?
the next one will be the stability. Yeah, and that'll be the
Stability.
last one. There won't be any. I think once we're there, that's really where it ends, other than potential issues with overdensification. But we're encouraging people right now. We're not there. We don't have an overdensification problem, and we want to get these really solid backbone nodes in, and those people are going to get an NFT to protect themselves. So it's a great time to deploy GeoDnet. But that's right. We started off keeping it simple, just get the miner, get it installed, and then encouraging people to make sure the antenna is good. We started tracking the total number of satellites, and now you'll see displayed the next step that we implemented just recently is effective satellites, which is meaning that the satellites that have good quality signal to noise ratio. If you have satellite that's not tracking well, then that's not really a useful data to us.
Sure.
And if you look through, you see there's variation, right? Not everybody has got them deployed perfectly, and we want that, and so we're going to be as proactive as we can be. We would like everyone to be getting um, the most token rewards possible, because that means the quality of our network is really strong, and that's what our customers want. They want high quality data,
Yep.
and so that's going to be a win-win for
Yeah.
everybody.
Yeah. I mean, at the end of the day, with all of these projects, whether it's yours or anything, is I always look at this like deploy it as if you had the use of the network in the highest, like that's the highest goal. And so making sure it's stable, making sure it's good, and then assume that eventually all of the networks will optimize for all of the different variables on that, whether it's signal strength or SNR ratio or how much it moves or how many other
Right.
miners are in that area. Let's see. There's a dude, Hendrik Engelking. What a great name, Hendrik. What is it with a high fixed device UI? Can we expect progress for less black boxed feeling? I sent an email and my device was fixed, but I didn't get any feedback as to why. So yeah, I get it. Like you want to know what's going on, but I think yeah, good.
Yeah, I think we can do better on that. And this is one of the things why we are looking to raise some additional investor capital for this, is to try to clean up some stuff. We are a small team. We're supporting a lot the full mining community, and then we're very engaged also on the user community to make sure that we have revenue coming in for the network. That's a huge, uh, you know, we think that's really important to, traditionally marketplaces where you have a supply side and a demand side, they grow a little bit of the supply side, then they grow a little bit of the demand side, then they grow a little bit of supply side, and then a little bit of demand side. Think about Airbnb was built that way.
Yep.
They didn't all of a sudden, Airbnb didn't turn on and one day have Airbnbs throughout the world. And I think the GeoDnet approach, crypto helps change that, where you can build out supply side much faster and much more scalably than in
Yep.
that model. But we're, as a project, a little bit on the more conservative side, and we're harkening back a bit back to, look, we want to grow supply and demand kind of simultaneously, a little bit hand in hand, so that we don't get way out of whack on one side or the other. So we don't have this huge bandwidth. All the things we'd like to do to better support the mining community, some of those are limited by the resources we have and the
Sure.
fact that we are putting a lot of emphasis onto making sure we grow the demand side of the network as well.
Yeah. It's
Uh,
like I will fix it and we'll tell you how we fixed it later, but for right now it's
Yeah,
fixed.
but in general, the firmware stability is improving. We haven't gone auto update yet. We should do that soon. If if you want to circle back with us on what happened, I'm sure we can provide more detail
Cool.
with.
Yeah, I thought it sounded ping you. Let's see. I think it's Maya again. Maya Sybil. Hopefully, I'm saying this name right. I'm reading off the notes here. Is asking if you got a couple stations that are close by, which station gets used for corrections? It's the
Yeah,
first
so
one I have.
you're kind of on the right track there. It is sort of an average. There's a couple different algorithms that are used, but for RTK, people call it network RTK, or a virtual reference station, and that in effect is basically creating, when a device comes in and says I want corrections, the network responds by providing corrections that is kind of a blend of several stations that are nearby to each other. So that's what network RTK is, NRTK, or VRS networks. Or you'll see these terms used on websites like Trimble's website and so forth. That is how it works. There's another algorithm that works in an even broader, more global optimization point of view, which is like the PPP and PPPAR, where you're taking that data first from the global network to get clock and orbit data products, and then you use a local network to get your ionospheric space weather correction. So that uses even more stations kind of aggregated together to create the correction stream. And those are the two most popular. There is a simple case, the original case, which is called single base, and that is where I just figure out, okay, this space station is the closest one to me. I'm just going to directly use that data.
Okay.
So that algorithm also exists, and people still do single base, even though these better, more sophisticated approaches exist. And single base works too, and that's literally, okay, Nick's miner is the closest to my GPS receiver. I'm just going to use his data and his data alone.
Dig it. It's the whole thing is pretty cool. I think. I mean, I've got a bunch of bunch of questions I could keep talking forever about. I think the location stuff you guys are doing is fascinating. The different reses and how we're thinking through those things get rewarded, because this idea that a network can be built with a little bit of a guided hand for a much more efficient network is probably kind of the killer app for spatially important networks. So kind of cool to think about. But we've also
Yeah,
run into some stumbling blocks where you,
we just keep on focused on this end goal of we need to create a network that is better than the Web 2 guys. And so
yeah,
that means you need to, you want to get the benefit of the blockchain community and the decentralization. Those are absolutely fundamental, huge benefits that you have a decentralized network that, you know, multiple people can make the hardware. You can contribute the data in a permissionless, trustless fashion. So having the hardware and the protocol support to allow, untrusted nodes to come on the network and be rewarded when they produce good data and to know it without any a priori central authority governing it. That is just a phenomenal benefit to creating a resilient network. But at the same time, you can't have all the nodes in LA. That just doesn't work. They can't all be in downtown San Francisco. So you have to
right,
also think about how to design the incentives in the protocol to get that's to match what something like a Verizon does very well, which is get that one last base station that's needed to get that a little bit of extra signal coverage. So you get one better bar and you can make your phone call in a place that doesn't work on AT&T, right? I mean, I think everybody knows that. I mean, it's to this day here in Silicon Valley. I mean, I use AT&T, but the coverage sucks. I drive from Palo Alto to my office, and there's two places where every single day, the call will go basically drop.
right,
And it's like, really? Silicon Valley, AT&T still can't get basic cell coverage in Palo Alto? And I'm,
yeah,
on Verizon, it'll work great. And so that's a big difference in value proposition.
yeah.
And so we want to use all the power of blockchain, but couple it with a Verizon like mentality towards getting a quality system built.
Love it. Yeah, no, it's cool. You just kind of take the best of what's gone before you and build something rad with that. We got just a couple minutes left. I might as well do this LoRa question from Hendrik again. So what about the plans for the LoRa module? I think you talked about this a little bit, but is there an option to make RTK correction signal for close by with LoRa?
Yeah. So I think we can downstream data. You can't make a base station run on LoRa because there's not enough data, not enough bandwidth to upload data. But you can go downstream with LoRa, and so we could do a LoRa-based puck or tracker node um, that would have the ability to do high precision positioning. And this is something I'm super interested in doing. It's just one of those things we haven't gotten to. We got pretty far. We've got, inside the HiFix miner, there's a mini PCIe slot. We've gotten some of the LoRa concentrator cards. We've gotten them into the HiFix miner. We've written code to talk to him and send packets out. But now there's still like 3 or 4 more steps to do. And then when we did the launch, we got super busy doing this and doing that, and we haven't gotten back to it. It's one of these things that we really want to do. When we have a bit more resource, we'll definitely do it. We may try to at some point get a helium grant to help with it. All these different things are possible. It's really cool, and we want to make it happen. It isn't in the GNSS community where our customers are. It isn't like job number 1 or 2 because there are not a lot of people using that capability, and it would take a bit of a sell to get them to do it. And then from a miner perspective, there's a lot of things that miners are asking for to make their lives better in terms of deployment. And so both of those buckets we prioritized higher than supporting LoRa. But yeah, it's something that I think would really just be a cool demonstration of all the cool things that have come in blockchain and using them all together to do something really neat.
Love it. Love it. Well, I could talk further about GeoDnet, but we're kind of at the end of the hour here. Let's
Cool.
see. Yeah. Anything else that you want to hit before we sign off? And thanks a ton to folks who've been watching.
I think watch the space. A lot of stuff's coming. I think it's a big market and it's a well-established market, and we're working hard to put all the pieces together to um, build a true decentralized blockchain solution to a problem that has been there for a long time. And certainly there are solutions in the marketplace, but they're expensive and they're not scaled. And we think that blockchain can fundamentally solve that problem in a way that's never been done before. So keep your eyes on the project, and we got a lot of new things and exciting stuff to come.
Right on. Love it. Thanks, Mike, for coming on. Thanks to everyone who jumped in on the chat. I just see Sierra just came on, Ricardo and Hendrik and Reuven. Good to see you in there answering questions. I saw a bunch of folks in there. Just contributing to the conversation. At the end of the day, this is what I want for this channel, is to make sure that you have an educational resource. You hear kind of directly from the mouth of the folks who are doing it. And you get the best information possible, so you can make a well-informed decision. So,
yeah, I really appreciate it, Nick, and I think you're an incredibly good interviewer. So, one of these days you'll probably be on Fox News or CNN or something like that. Who knows? I mean, you're good at it. You're good at it. Appreciate your great questions.
Yeah. Dig it. Well, thanks a ton. And I will see everyone else on Discord or Twitter or wherever else I see you. Until the next time, Mike, thanks a ton for coming on. This wraps up another Gristle King interview.
Cheers.
Bye-bye.